Hey everybody, I'm wearing a hat today. The hat's green, my shirt's green, and I even have this bracelet that I stole from my fiance that she made with her friends that says Starbucks lovers, which is green. Kind of. Some of it's green. It's day 3. We're about to do some more Advent of Code stuff. So if you missed day 1, day 2, we already have 4 stars here. So if you're new to the series, how it works is I'm going to open up a new puzzle every day of the year, or every day of the year, every day of December. We get a new Advent of Code problem, and I haven't seen it yet, so we're going to open it up together. And what we're going to do is we are going to solve it from scratch. So on the left, we'll have code. On the right, we'll have the output of that code. And then hopefully, by the end of the video, we'll get the right answer. There's going to be a part 1 and a part 2 for every problem, and that's how you get 2 little stars here. So yeah, let's dive right in. Let's see how it goes. I'm going to scoot in a little bit closer, and let's see what our elves are up to on day 3. Okay, day 3 gear ratios. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take you long to find the gondolas. Why am I saying gondolas so weird? That was weird. The gondolas. When it was plural, I figured it out. Anyway, sorry. It doesn't take you long to find the gondolas, but there seemed to be a problem. They're not moving. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. So the engine schematic, which is our puzzle input, consists of a visual representation of the engine. There are a lot of numbers and symbols you really don't understand, but apparently any number adjacent to a symbol, even diagonally, is a part number. It should be included in your sum. Number adjacent to a symbol, and then periods don't count. Okay, so these are symbols, I guess. So here's an example of the engine schematic. So in this schematic, 2 numbers are not part numbers because they are not adjacent to a symbol. 114 in the top right and 58 in the middle right. Cool. Every other number is adjacent to a symbol, and so is a part number. Their sum is 4361. So if we add up this, which is adjacent to this, which is adjacent to that, this, that, and then I guess this guy here, this guy here, this guy, and this guy. Cool. So if we add those up, actual engine schematic is much larger. What is the sum of all the part numbers in the engine schematic? Okay, so yeah, so this is how the puzzle starts. So how we always start these videos is we copy this puzzle input, and then we paste it here. So if I hit run, what you're going to see on the side is this is our puzzle input. If we want, we can use Elm's string.lines function to break this into a list of lines. I don't know why the text isn't wrapping. It's unusual. Oh, it's probably because I did this. I don't know what's going on. Anyway, usually that text wraps. White space pre. I don't know. I did something silly. Okay, let's just roll with it. I'm just gonna get rid of all this stuff. And oh, it's really weird. I thought that this would be max with word wrap, white space wrap. Well, that throws a wrench in the video. Anyway, here's how I was gonna go. So what we're going to do is we are going to take all of these things, break them into these separate lines, and then we're going to try to figure out how we can parse out these numbers, parse out these symbols. What I'm thinking is we can scan for non-numeric symbols and just kind of have a mapping of like which coordinate has which symbol. And then for each number, we find we can just kind of check each coordinate around the numbers and then see if the the number has an adjacent symbol. And then from there, we'll just filter numbers. So with each line's going to have its own coordinate. So like 4 would be at 0, 1, 2. I can't tell if I want to like have like all these things represented in like 2D space. So I say like position like 0, 0 is 4, position 6, or 1, 0 is 6, and then like have a function that runs at the end that groups them together, or how I want to do that. I think that's what I'm going to start with. So what we're going to do is we're going to take these strings, we're going to go through each line, and if we use an indexed map and we use this tuple.pair function, what it's going to do is each line is going to be paired with its index. So you're going to see, oh, now it's wrapping. I don't know what the heck's going on. So what you're going to see is that each line has like its y value on the left, and then what we can do is for each individual value, we can say we can loop through and start to build up a data structure that like tracks the positions of all these characters. So I think that's what I want to do next. I think for this, I'm going to do list.map, and I'm going to say, we'll do a list.foldL actually, and we'll start with an empty dictionary. We haven't used dictionaries this year yet, but Elm's core library has a dictionary type that allows you to map values from like keys to values. So we're going to have, I'm just going to call it a lookup, and it's going to be a dictionary that maps coordinates. So XY coordinates to characters. So the character might be the number 4, might be this asterisk, and we're not going to represent periods. We're going to treat those as white space. And so here I made up a coordinate. That's not defined. So we're just going to say a coordinate is a pair of numbers where this is the X position, this is the Y position. And because we're using tuples and basic values, the dictionary is going to be happy. Dictionaries in Elm are restricted. You can't use any like fancy data structures, but you can use primitives, and tuples and integers are primitives. So this will all work out for us, hopefully. And then I'm going to say to lookup or update. I'm going to call this our grid. Let's call this our grid. So we have a function called update grid that we're going to define here together. So how foldL works is it starts from left to right, and it's going to go through all of these things, and it's going to call this update grid function. So our first element that's going to come in the list is going to be a pair of integers and our line value here, this string. And then what we want to do is we want to take in the current grid and return the new one. At first, it's just going to be empty. So that'll be the input the first time around, but then whatever we return when this thing comes through, we're going to come back and have that updated value for the next part. So I'm going to say this is the Y index. We're just going to call that Y actually. And then we have our grid, and what we want to do is return an updated grid. So maybe we end up inserting something, at 0, at some XY value. And we say, oh, we found like the 4 character. So that's kind of how this function works. And then by the end of it, we'll have a nice dictionary. So if I hit the run button, what we're going to end up with is we're just going to see an empty dictionary. You'll see dict from list and an empty string because we never insert anything into our grid with this code. It starts empty, and then we do nothing the whole time. So that's not going to do much. So to get this to work, what we need to do is we need to loop through this string, And the way we're going to loop through a string is we're going to start by taking the line. We're going to take that string, we're going to turn it into a list of characters. And if you're curious where all these things are coming from, we do have, if you click this link here, it's going to open up the Elm package docs. So all this stuff is available online. You can browse through it. If you ever want to look up like what functions do I have available, the core docs are a great place to start. So this is all the code we're going to be using today is going to be in here. So what we're trying to do first is we have a string. We just want to break it into a list of characters, and that's what the string.toList function is going to do. So it's going to give us A, B, C in that order. So what I want to do is turn this into a list of characters. I'm going to use some comments here to help visualize what's going on. So we start with a string, right? Because line is a string. And then when we call string.toList, we're going to get a list of characters. So now that we have a list of characters, we can do that index map tuple pair thing again. And what the tuple pair function does is it just takes the index and it takes the character in the list. And what this would return would be a list of ints with characters. But what I want to do instead is say to key value pair. Maybe more specifically, to coordinate char pair. So these are the types of values that we want to return. So really what I want is the x and the y to be the first element, and then I want to say what character is there. So what we can do here is we can say, if you give me a character and like an x value, I will give you back this coordinate character pair here. So x comes in, we'll have each character come in, and what we're going to do is we're going to return our x and our y. And then hopefully by the end of this, what you'll see is a list of these things here. So these are going to make it, actually, this is just a nickname for coordinate. So let's call it coordinate in our type annotation. This is what type aliases are really nice for. They help kind of cut down on all the noise that we have here. So it's going to loop through each individual character, and it's going to take the y value from the row that we passed in, and it's going to take the x value. And hopefully by the end of it, what we're going to see, let's do a list.map, and I'm just going to do a debug log here. And let's see what gets printed out in the logs. Oh, and I'm going to comment this out and comment this out for a second. So if we just did list.map, update grid, just comment this out for 1 second here. This will print basically what we've done here. So for each individual, maybe this is actually better. Map. What this did is it created a mapping of, instead of just having a big block of text, now what we have is a list of keys and values. So what we want to do here is we don't care about these periods. We can just filter those out when we start building up like what coordinates have pieces in them. I actually kind of like doing this first instead of doing the update grid function. I think this is a smaller first step we can have. So we can say to coordinate character pairs. Let's call this that. And then let's do that. So what we're doing is we're going to take in each of these, and for each one of those, we're going to return this. I like that a lot better. I think that's just, that's easier to work with. So let's compile that again. Cool. So this is our first step. So we went through, we looped through each character, and we said, what is your position in the grid? So 0, 0 is our top left. And then at the very end of our list, we're going to have 9, 9, which is a period. And if you look 2 to the left of it, you'll see 7-9 is this 8 character over here. So that's what this code did so far. So now we're left with a list of these coordinate characters. Here we had a list of just the y values, and then the full like line. And then here we had a list of strings. So every time in Elm that we use this pipeline operator, we're kind of transforming our input one step at a time. And now that we have a list of coordinate characters, what we can do is we can start to make a data structure that would be helpful for us. So what I want to do is I want to drop all the coordinate characters that have periods in them, because I don't think they're going to be helpful for the puzzle. So I'm going to say list.filter, and I could say is not period character. So a list.filter isn't going to change the type of this value. All it's going to do is it's going to return less items in the list, and it's only going to keep ones that pass this test that we write. So because we have these coordinate character pairs, we will return true if we don't really care about the coordinate, if that character value is not equal to a period. And so hopefully what this filter line does when we use this function is it filters out all of this noise here, and gets rid of all the periods here. So now all we have is 4, 6, 7, 1, 1, 4, star 3. So all those periods got dropped, but we didn't lose information about the position. So notice that we still have 0, 0, 1, 0, and 2, 0 for 4, 6, 7, but 1, 1, 4 doesn't pick off at 3. It starts at 5, which is actually the position in the text that we started. So now that we have this grid, and we have the coordinates for each character, I think this is still enough information to solve the puzzle that we want to solve. So what we can do, I think next we're going to have to distinguish numbers from symbols, and then we're going to need to start grouping numbers together. So if we have numbers in a line, we're going to want to make it so that, like if we're here at 0, 0 and we only go up 1, this isn't just the number 4. This is going to be, 467, etc. So I think what would be nice here is if we had a function that turned this into a data structure that was a little bit more helpful. So we could, figure out, okay, these are where our numbers are, these are the ranges that they're at, and then here are our special characters. We don't really care about, whether it's a star or a hash or whatever, but what we do care about is there a character here, yes or no? So I'm gonna, before I start typing this, what I'm gonna do is I'm gonna describe the data structure that we want, so that we can run logic on it. So this is gonna be our, I'm just gonna call this a placeholder name structure. You can call it thing, it doesn't matter. We're gonna come back and name this once we kind of see what the fields are about. So we have this thing. It's gonna have a list of numbers that we care about. So we're gonna kind of go through the numbers and filter out the ones we don't want. So we're gonna say numbers, and it's not just going to be a number, it's going to be a number with a coordinate range. So how the coordinate range is gonna work is we're gonna have, I'm doing this all online right now. We're always gonna have the same y value, but we're gonna have like an x range, I guess. So here, let me just make this all one record. We have the y, and then we have the x range, which is going to have a high and a low. So for example, the first number in this list might be 467, and it goes from 0 to 2 on the y. The y would be like 0 here. So that's like, that would represent 467. We need to kind of group these digits together into a number that we can work with. And then we want to have a list of places where we found special characters. So let's look at the puzzle. Let's see what they call those special characters. Symbols. So symbols is going to be instead of a dictionary, what we can use is we can use a set here. So a set is kind of like a dictionary that doesn't hold values. It only holds like our coordinates. So if we have a set of coordinates, we can use this set type to say like, hey, is there a member at this coordinate? And so we can give it the set, and it can say yes, there's a symbol here, or no, there's not a symbol here. So I think that's a good data structure choice for our symbols. And then we're going to have a toThing function that takes in our list of coordinates. And what it's going to do is it is going to return this thing that we want. And so if we add this to our pipeline here, hopefully the result is instead of having a list of these coordinate characters that are kind of hard to work with, we have that data structure we care about. So I'm going to take a look at the puzzle input to get inspiration for what to call thing. And it looks like engine schematic is the words they're using. So let's call thing schematic instead. And that'll make me feel less dumb when I'm talking about this. So the schematic has a list of these numbers, number at range, and then I'm going to call number at range that shape that we described earlier, where it has a value, it has a range of x coordinates, and then y coordinates. So a really common thing to do in Elm or any functional language is that you kind of break apart the problems into tiny parts that you can work with. So instead of trying to do everything in one giant function, we're just going to have itty bitty functions that all kind of combine together. So I'm going to call this coordinate chart list. That'll be our input. And then what we want to do is ultimately return something here and then something here. So if we wanted the answer to be wrong, number at range, we would just say there's no numbers in our schematic. We're going to ignore everything. And there's no symbols in our set. So what we can do is we can make little tiny functions here, like toSymbols, where we give it the coordinate character list. And then we can define our own function here, add some white space here, where instead of returning a full schematic, all this function cares about is just returning the set of coordinates. So it's going to filter down our coordinate character list, and it's only going to keep the coordinates that had values. So let's ignore numbers for now, and let's focus on how are we going to go from our list of characters to this coordinate list. So as a placeholder, I'm going to start with set.empty. So this is where we are now. What we're going to do is we are going to try to, let's just for debugging reasons to kind of walk through this step by step, we want to turn this into only a set of the symbols that we found. So only the coordinates that have symbols we want to keep. So if we do our job right, we will have 3, 1, we will have 6, 3, we'll have 3, 4, 5, 5, etc. But all these numbers will go away. We don't care about the symbols. We'll throw away what the actual characters are. So hopefully that makes sense. So what we're going to do is we are going to say, let's take coordinate character list. Let's filter it down to isSymbol. So isSymbol is going to be a function that we write. And then once we have some way of doing that, we can say set from list. Or we have to say set or list.map. We only care about the coordinates, which is the first member of our little tuple. A tuple is just fancy words for a pair. And then we'll hopefully be able to only have a list of symbols here. So how do we know if a character is a symbol? We'll have to define that here. So a character is a symbol if it's not a digit. So if it's not a digit, and we've gotten this far, then it's a symbol. So we're going to do not is digit. list.filter is symbol. Oops, this is going to take a coordinate character pair. We only care about the character. So we use an underscore and elm to say this is an argument that we're ignoring. We're not going to use it in our calculation. And so this is what we start with. And then when we run to symbols, you'll see that we only have the positions of our symbols. So we kind of discarded all that information. And what's great is we can be able to say things like, hey, is there a symbol at, position 0, 0? And it'll say, is this a symbol? No, it's not. But we can say, is there a symbol at 0, 1, 2, 3, 1? So now we have a data structure where we can ask it, is there a symbol here, yes or no? And then if there is, set.member will tell us if there is or not. So what's cool about that is when we have our big data structure, it's going to have symbols to help us figure out where things are at. And then we're going to have this numbers list, which is going to help us loop through something, filter out values, take the numbers that did have symbols near them, and then we can add them up. So that's the next step. So let's do numbers next. So how we have to get to these numbers is we're going to have to make a similar function to symbols. But instead of returning a set of coordinates, what we want is to return a list of these numbers at certain ranges. So here, if we wanted it to be wrong, we would say it's an empty list. But ultimately, the data structure that we're looking for at the end would be something like this. So we'd have a number, we'd have a y value. And so for this number, the y value would be 0. And then we would have a range of 0 to 2. So if our code worked correctly, this would be the first element of our list. Oops, sorry, this would be the first element of our list. So this would be what we'd want to see, but it wouldn't just be for this, it would be for every single number. So we need to write a function that takes the next coordinate and character and then kind of accumulates like, hey, am I still building up a number, or is this like a new height? Whew, so that was a lot. Let's see if we can do it. So list.foldL, I'm going to say update numbers. This will be a loop. And then the initial value for our list of numbers is just going to be empty. And then we're going to take our coordinate character list. I'm going to use the pipeline syntax for this. And what we want to do is have this update numbers function figure out kind of where we're at in our equation. I don't think a list of numbers is actually going to be enough. So what we're going to do is we're actually going to have a data structure that's keeping track of the last thing we saw. So if we didn't see anything, it'll be nothing. And then numbers is going to be our list of numbers and ranges. Let's make a little intermediate data structure to help keep track of this. Number info. We'll just call it that for now. So the last thing is going to have, maybe I saw a number, or maybe it's like a number string. So maybe I saw 4, maybe I saw 4 and 6. We're going to append that to the string. And then this will be the output that we want. I think this is the right way to go. We're kind of doing this real time, so maybe this is crazy, but this is where I'm starting. So we're gonna have a y value. This is the last thing we saw. We're gonna have a y value, we're gonna have an integer, or we're gonna have, and then we're gonna have an x range, x start be an int, and then x end will be an int. So let's see how this goes. What would update numbers look like if we took in number info and had to return an updated version of that? how would this loop look? So we would have an X and a Y, we would have a character, and then we'd have this like info thing here. So our goal is to try to eventually spit out something like this. But we're gonna need to kind of keep track of where we are in like the list before we can do that. So what we're gonna start with is we're gonna have 4, 6, 7, 1, 1, 4. Should I filter out the things that are digits? Is that it's probably a good place to start. So we only have numbers. So I'm gonna do that. We have a character, we're gonna have a coordinate character list. I'm gonna make something called isDigit. And what that's gonna do is it's gonna return if the character is a digit, and then isSymbol is gonna be basically the opposite of this. Is it not a digit? So we could use character digit here again. We could also say, it's the opposite of isDigit when you give it that pair. But what I think I want to do is before we do this fold, I want to just filter out to only have the digits. I don't want to keep the symbols around. So let me just print out where we are in this process. Digit grid. So here in the logs, this is after we filtered out all the digits. Now there's no characters here. So now we're just going to get basically these pairs that have the coordinate, has the character, but we don't have to worry about any symbols and stuff getting in there. So update numbers can assume that this is only ever going to be numbers here. And I want to keep them as characters just because I'm going to want to append them together. So this number string we have. Okay, so we know that the character is going to be a number. What we have to do is we have to check the value of info.last. So are we at the beginning of a string or are we starting fresh? So if there's no information, this is a new string. So what we need to do is we need to say info is going to equal, we're going to return info, but we're going to update last to have a value. So what is going to be the first value of this data structure? I should give this a name. I'll just call it last. The naming here is a little bit weird, but yeah, we'll just we can clean that up after if it starts to become a problem. But what we want to do is we want to say what is the current number string, or maybe we just do a list of characters. Let's call that chars. So we'll start with just the first character that comes in. So 4 would come in. We would make this a list with just the number or the character 4 in it. And then what's our y coordinate? It's going to be whatever the y coordinate of that first character is. So it would be 0. Our x start is going to be x. And then our x end is also going to be x. So if we stopped right here, if 4 was the only thing in the list, then I think we'd be good. So, so that's that. So that's what would happen if this was our first time adding a character. So this is like this would be like adding like this new last value in. Oops. And then what happens if we do have a last value? What we want to do is we want to see if the coordinate, the x position here, is one more than the last x position that we had. So we can say if last.x end equals our x position minus 1, then that means that those numbers were next to each other. And if so, we want to update our last to be what it was before, but our characters are going to be all the last characters that we had. So if we're here, we already have 4 in that list. We want to add our new character 6 to that list. And then we also want to update the x end position to be the x value of the 6th character. So it used to be 0, now it's going to be 1 that we're writing. And I'm going to format this so we can see it a little bit better in a bit. So sorry that this is all kind of wrapped on you in a weird way. This will get cleaned up when we click the format button. We're just not in a good place for a format here. I'm just going to do this to see if we can format. It looks like there is a syntax error. Oops, one more of those. Cool. Sorry. So that kind of snaps things into place, makes it a little bit easier to see, hopefully. And then I'm going to do this too, so that we see these on new lines. So if it's our first time coming through, let's just kind of like walk through this like we're the computer. We're going to say this is our value. So we want this to have a 4 in it. We're going to want the y value to be 0. We're going to want the x value to be 0. And we're going to want the x end value to be 0. So if we already have something, so that's it for the first loop. It returns this. This is our new updated data structure. It's an empty list of numbers, and then last equals, just this. So then we come through with the next item in the list. This is how the list fold works. It'll pass these in one at a time. And we'll have updated value here that we returned last time. So we're going to hit a different branch. And so we're going to end up with is x end is going to be the 0 we gave it before. And then our current value, x minus 1, is going to be 1 minus 1. So 0 equals 0 will be true. So then we'll hit this branch. And so info last, we'll update again. We'll say keep the data structure that we made before, but we need to add the 6th character in. So now our list is going to be 4, 6. And then we're going to say and kind of push the end range for our x up to 1. It used to be 0, push it up to 1, because next time we come to the list, we're going to want to hit this 7. We're going to hit this 7. So it'll be 4, 6, 7. And then our x end will get bumped up to 2 because 1 will equal 2 minus 1. And this condition will be true. And then we're going to hit this one, 5, 0. And this is a branch we haven't handled yet. So we do have a value for last in our little loop that we're making. But this time around, 5 minus 1 is 4, and our x end was 2. So 4 does not equal 2. We're going to need to do something else. And so this is when we're going to insert. We're going to take that last value, and we're going to put it into our list. So we're going to say whatever our numbers were before, that's perfectly fine, but we're going to need to say from last to, what was it, number at range? Number at range. So we're just going to have a function that takes in the thing we were accumulating, and what it's going to do is it's going to update this. So you can see this code is actually it's going to be reused in both branches. So I'm gonna move this to one thing before we get too ahead of ourselves. So this is going to say new last. So this is a last value. And then rather than duplicating this logic in 2 places, what we're going to do is we are going to say, in this case, we're going to want to kind of reset the list to start here. And then all we need to do is update this from last to number at range. So this is going to take in a last, return a number at range. And honestly, they're really close. Like they're like super close to the point where I kind of feel stupid. So how this works is I'm going to bring both of these types down here so we can kind of look at them side by side. Where's the number at range? Here it is. So we're going to turn it into this data structure. The only important difference is that we're not going to be dealing with a list of characters. We're going to be dealing with a solid number. And if we can't get a solid number, that's totally fine. We're just going to discard that information. So let's make this return a maybe, because it is possible that we have an empty list for some reason. In that case, we're going to need to handle that. So we can say if we take our characters, which in this scenario would be 4, 6, and 7. If we take that, we make a string out of it. So we go from 4, 6, 7. This is where we start. So we start there. We're going to kind of smush them all together into this. And then we're going to try to use string.toInt to give us a maybe number. Maybe number is going to be all that stuff that I just described. So this could succeed, this could fail. It depends if our characters are actually what we think they are. So here, what I was saying was an example value might be this. And then when we call from list, we're going to get something like this. And then once we call to int, we get something like this. If our list was empty, this would be an empty string, and then we get nothing. And that's why we need to use a maybe to handle the case that something crazy happened. But I think we're in good hands here. I don't think that our code will do that. But I'll make sure to, that we handle those cases. So if we don't have a number, we can't do anything. So if we have an invalid number, we can't give you a number at a range because it is expecting a valid number value. But if we do have a number, what we can do is we can create a number at range. So we can say the number field is going to be that number. We're going to say that x range is going to equal our last.xStart and our last.xEnd. And then finally, our y value is going to be our last.y. And because we're returning maybes, we'll say we always succeed in that case. We're going to use adjust for that. Cool. All right, let's format this. Let's see where we're at. So this is almost correct, but it's not perfect because what's going to happen is we could have a number at the very end. Let's say there was an 8 here, like that, if this was our puzzle input. And we could get here, that would hit this branch, and it wouldn't append our number 59828 to our list. So as one final step, instead of doing this, let me undo these changes so that we have our original puzzle input. Instead of adding that to our list of numbers, it's going to just like drop that number, and we don't want that. So what we're going to do is we're not going to use two numbers. We're going to say from number info to number at range list. It's a very long name, so I apologize. But what we're going to do is we're going to do a cleanup in the final step here. We're going to take this and we're going to turn that. And so if we do have a last that wasn't cleared, we're going to make sure that we append that to our list. So case info last of nothing, then that's fine. We'll just return the numbers that we had. But if we do have a last value, we're going to do the exact same line that we had here. And then, oh, sorry, this is, it's going to be a list. Let's return, instead of a maybe, let's return a list. This is just going to make it a little bit easier to work with because we're going to be doing appending. So we're going to use this to represent whether we had a value or not. So what we're going to do is this for our last line. And this is going to guarantee that any dangling numbers don't get lost. And then I have a capital L somewhere that I'm not supposed to have it. Type alias last. Oh, I copy pasted, didn't I? There's two lasts floating around. Yeah, there's the other last. So I'm just going to delete that. And now I think we have our data structure. That was all just parsing, right? I don't know how long that we've been recording for, but we've been just parsing numbers forever. So what we're going to have here is our data structure that's going to be like useful to read. So let's just quickly look and just make sure that this looks okay, and then we can do the logic on it. So 467 is the first number we see. That's right. And then the range is starting at 0 and then going 1, 2. Perfect. 114 is the next number we see. Then we see 35. Then we see 633, 617, 58, 592, 755, 664, 598. That all looks good. I'm going to do this one thing to show you that we are getting our last number, 598, and just to quickly show you what would happen if we didn't do this special logic at the end. So if we kept the old logic of dot numbers and we didn't use our from number thing, watch this 5, 9, 8, 10. That just disappears. So our puzzle would be wrong. So that was why I added this weird code at the end. Hopefully that clarifies enough. Justifies my crazy premonition thinking. So I'm going to delete all these. So we have a schematic at this point. So this looks right. I'm just going to do a random spot check. 592. It says it's a 2, 4. So that is the second, third, fourth. That's right. And then it says it's on index 6. So 0, 1, 2, 3, 4, 5, 6. I think we're good. So all we need to do now is we need to basically just query around these ranges. So for 467, we're going to loop through each of these numbers, and we're going to say, give me all the adjacent squares. So we're just going to make a function that takes the numbers and returns the adjacent squares. So this is going to say two numbers with adjacent symbols. So this is like the final piece of the puzzle. We're not parsing strings anymore. So this is going to be good, I think. So what we're going to do is we're going to make one more function. I'm just going to put it up here at the top so that we can work with it and see our puzzle input. And what we have is a schematic. And what we want to do is we're going to eventually want to return a list of those numbers. So like 467 passed, 114 isn't going to be in there, 35 is going to be in there, etc. But I'm going to leave this off for now so that we can kind of slowly build up towards the answer. So let's start with just keeping things the same, return the schematic as is. Now we're going to say let's only look at the numbers. So now we have a list of these numbers. And what we're going to do is we're going to filter things that don't have symbols. So we're going to say list.filter, say has adjacent symbol. What we can also do is say take these things, take these numbers and map them into something that has like a list of the coordinates around it. So let's start with just this idea, has adjacent symbol. And I'm going to pass in the whole schematic again. Has adjacent symbol takes in a schematic. It's going to take in one of these number at range values. So a single one of these that we have highlighted. And it's going to return a true if we should keep it and a false if we shouldn't. So schematic, we've got our number at range, and we're going to return a true if we want to keep it in the list. So this would keep all the items in the list, but if this failed for every single item, we would have no numbers at the end. And then what we can do here is we would be able to sum up the numbers. We would be able to say all I care about is the number value, and then we're going to sum it up. So in this scenario, our sum would be 0, and in this scenario, we would add up all the numbers and get 4533. But we know that's not true because we haven't implemented this correctly, right? We're always returning true. So I'm going to just comment this out for a sec. And then what we're going to do is I'm going to just make this a map temporarily so that we can walk through what this function is returning. So if we have our number at range and we take the x range, this is going to give us kind of like 0 to 2, 5 to 7, etc. What I want to do is turn this into a list of coordinates, I think. So let's expand this out. We'll say list.range. Grab the first part. So the start kind of wish that we just left these as 2 separate fields now. So this is going to give us 0, 1, 2. This is going to give us 5, 6, 7. This is going to give us 2 and 3. And then what we're going to do here is we're going to pair that with the y value. So we'll say list.map. We're going to have our x values. And what we want to do is return x with the y position. So if I do this, all of these lists of numbers are going to be lists of pairs. So now we have a list of our coordinates from before, list of our coordinates from before. And what we can do is we can say for each one of these, let's take our coordinate, so one coordinate at a time, and what we're going to do is we are going to find the adjacent coordinates. To adjacent coordinate. So each item, sorry, so I have a range, so that, yeah, each item to adjacent coordinate. This will take in a coordinate like 0, 0, and it's going to return all the things around it. This is going to be a list of coordinates. So this will be an x value and a y value, and it's up to us to return the top left corner. And we don't have to worry if things are out of bounds because we're just going to query our set and see if there's a value there or if there's not. So these are all of our values on the y -1 row because we're counting diagonals. And then we don't want xy, but we do want that. So one to the left, one to the right, and then finally, for our last set of coordinates, we're going to want to say bottom left, bottom, and bottom right. So I think this is a list of adjacent coordinates. So now these are all the adjacent coordinates for 0, 0. Oh, this is a concat map. I don't want that. Well, I guess that's okay. These are all the adjacent coordinates for 0, 0. We concatenate it with that. What I'm going to do is I'm going to use set from list to combine these and kind of get rid of duplicates. And then what we can do is we can say, do any of these coordinates, if we take in our schematic and we return, do any of these coordinates have a symbol in them? So the way we do that is say, set dot any, I think. Set dot any coordinate. Set dot member coordinate, and then we can say schematic dot symbols, and this will return true if any of these have a symbol. So I think I made up set dot any. Dot any. I know there's a list dot any. Maybe we won't turn this into a list. List dot any. So look at this. And now we've got true, false, true, 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 false, true, true, true. So the second number, it's saying does not have anything. It's saying true, 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 and then it's saying this one is false. So I think we're actually getting the numbers that we want. So if we take map and turn that back into filter, and then we say we don't care about these ranges anymore, just give us the numbers, I think we've properly filtered things out. This is what the puzzle was looking for. So it dropped 114, that's not in our list. It dropped 58, that's not in our list. We can add back in these annotations here, these to numbers with adjacent symbols, and then if we want to sum it up, hopefully this gives us the answer that we saw, 4361. Let's go here, and the answer is 4361. So I think this is the correct answer for part 1. I'm going to add these annotations back in. I'm going to click format, and then I'm going to move this code down at the bottom here. So this is going to be parsing stuff. And then after all that parsing string stuff, we have the checking the schematic. So this is kind of the logic that runs on checking the schematic. I'm gonna hit format, and then the answer to this video here, I'm gonna say day 3, part 1. I'm gonna click the save button, and then I'm just gonna open up Notepad real quick and make sure that these are available in the video description below. So this is working for the sample input. Let's see if it works for our big crazy puzzle input. So this is a lot more numbers. And let's run this and see what we get. 512794. Okay, that was it. Okay, so that was part 1. So part 2, they're going to put a little twist on it. We'll see how it goes. Hopefully it'll be easy based on the way we've structured our code. Maybe there's going to be a twist. Like day 1 was very difficult, but day 2's part 2 was very easy. So let's take a look. Part 2, the engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump to the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola has a phone labeled help, so you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer, holding a phone in one hand and waving with the other hand. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear in any star symbol that is adjacent to exactly 2 number parts. Whoa. Its gear ratio is the result of multiplying those 2 numbers together. Wow. Okay, so now we do care about the star. So it's saying a gear with a star is adjacent to exactly 2 number parts. Its gear ratio is the result of multiplying the numbers together. So we would multiply 4, 6, 7, and 35 and get that. Second gear is the lower right because the gear ratio, the adjacent 617, is not a gear because it's only adjacent to 1 part number. So it's saying that this and this is what it's doing. Let me just make sure that the math here is right. I'm going to pull up the calculator. So I think what it's saying is that because these 2 are touching, we take 467 times 35, and that gives us 16345. And then what I'm seeing is the only other one where a star is connecting the 2, 755 and 598. 755 times 598 is this number. And so if I add that to 16345, then I get the answer. Okay, got it. So what we need to do is we only care about numbers that are touching with a star. We don't care about 114, we don't care about 633, we don't care about whatever. And what we want to do is we want to kind of group them by, are they touching the star? I realize now that it would be a lot easier to loop through the set and say like, hey, am I touching any of these coordinates? Or, am I within the bounds of anything? And then we only want to keep those numbers. So what we're going to do is we are going to say, we're going to change our definition of his symbol to only care about stars. That'll help. And then we'll see if we only get the adjacent stars. And then for each star, in each position of each star, we're going to loop through and say how many numbers are you colliding with. And if the answer is exactly 2, then we're going to multiply them together. If it's 1, 0, 3, we're not going to do it. So let's hop back over here. I'm just going to rename this. Oops. Yeah, that's already saved. I'll rename this to part 2. And let's get started with this. So before we did all the summing, let's just kind of comment this out. We left off saying that all these numbers were next to symbols. Now what we're doing is we're saying we only care about things next to stars. So is symbol is going to change its meaning. So it's not going to be, am I not a digit? It's going to be, is the character equal to star? So hopefully this, when we run this code, it's only going to return 467, 35, 617, 755, and 598. And that's what happened. Great. So we've filtered out all this other noise. So now we're just left with these numbers. If we take a look at our schematic is only tracking the position of the asterisks of like these things we want to multiply together. So what we can do is we can actually loop through our symbols, and then we can group. Or what we can do is we can upgrade this function to include information about what symbols it collided with. So maybe 467 can say like, hey, I found symbol, 3-1, this is coordinate 3-1, and then 35, and then we can group on those numbers, and then we can say, if there's any group with exactly 2 digits, multiply them together, and then last but not least, we'll add the sum. So I kind of like that approach of discarding less information when we get to this part. So let's come down here. Instead of using a list.any and having this Boolean, what I want to do is I want two numbers with adjacent symbols. What I want to do is say, map this. And so right now I think it'll just say true, false, true. Cool. So what I want to do is list.any. What I want to do instead of returning just a Boolean is I want to return which places have a match. So what would this look like? Would this return my adjacent coordinates? So here, yeah, so I have 3-1. This one hits 3-1 twice, but that's because I got rid of the set.fromList, set.toList. I think that'll get rid of the duplicates. Yeah. So now what I'm going to do is ignore anything with an empty list. So list.filter, list.is empty. Is it empty? And I'm going to use a horrible keyword here, not. Oh, it is empty. I love that. Okay, that's much better. So this is only caring about this. I'm going to do a filter map here instead of this weird filter at the end. And what I'm going to do is I'm going to say, this is going to be adjacent symbols. It's going to be a list of coordinates. Coordiantes. Adjacent symbols, I'm just going to return that as is. Make sure that we're in the same spot. Oops, I got to format this. Did I do something silly? Oh, I forgot to do equal sign. Cool. So that'll format that in. I'm just going to do this just to kind of get these things. Our lines. What we want to do is we're going to say case empty. We're just going to discard the number. But if we do have it, let's just return the adjacent symbols for now. So sorry if there's anything else. We don't have to do a case really, but what am I doing? Sorry. We can do an if statement. Let's do an if statement. That's easier to read. If list dot is empty, adjacent symbols, then we'll return nothing. Otherwise, we'll return for now just the adjacent symbols. So here we're going to have just symbols, and then we're going to have number, which is going to be the number at range dot number. And I think this will give us the grouping that we're looking for. So now we know 467 is near the symbol at 3-1. This guy here. And so is 35 at 3, 1. So what we're going to do here is we are going to group by adjacent symbols. So this is going to be a little bit of new logic that we'll write. So what it's going to do is it's going to take in one of these, or a list of these. So where we have these, and then a list of coordinates. That'll be our input. And then what it's going to return is, it's going to return a lookup where we can say, for this specific coordinate, what numbers do we have here? So this is what we want to return ultimately. So this is going to be our numbers. And then we're going to return something here. I would give this an annotation, but I should give this an annotation because we're actually using it in 2 places. Number near asterisk. I think this is our last annotation of the day. So I think we're almost out here with type aliases. Almost there. And then all I wanted to do was just have an annotation on the end of this again. Near symbols. And then I think this is going to be a maybe. Numbers near symbols. Is this right? Cool. All right, great. That is right. So I just wanted to add those annotations. So when you're looking at the code later, you can see what's going on. Format this. What we want to do is we want to say, all right, let's go through all these numbers, and then we're going to kind of keep track. We're going to take like the coordinates for each number, and we're going to insert the number in all those places. So I've got this number near symbols. What we're going to do is say, take your numbers, take your numbies, take your numbers, fold L. I'm going to say update dict here. And then we're going to say as initially, we're going to say there's nothing in our dictionary. And it's going to be up to us to take in a single number near symbols and then return, take in the current dictionary and return the new one. We've been using fold L a lot for this puzzle. So here we're going to have the number itself and we're going to have the symbols. I'm going to do a bit of destructuring here to save us some typing maybe. And then we're going to have the dictionary as it is now. We're going to return the new one. I'm going to do this just for formatting so you can see everything on one screen. And then what we're going to do is we're going to say, let's take those symbols and we'll say dict.insert. What do I do? Symbols. We'll say take each symbol. So that's like each coordinate, I guess. And then for each one, what we're going to do is we're going to say list.fold L one more time. We're going to take in the coordinate. And we're going to take in the inner dictionary. And we are going to return an updated version here where we just say, all right, insert at that coordinate this number. I think this will work. Oh, that's right. It needs to insert it, but it needs to be a list. So what we're going to say is dict.update. See how dict.update works. It'll tell us. So dict.update will take a maybe list. Sorry, this is so off the screen, you guys. I really apologize for this. All right, we're going to take the dictionary as is. In the case where, the list is empty, if the list is empty, whatever, we'll say case, maybe list of empty. Then we're going to say, we want to return a maybe value here. So update at that coordinate. If we already have a list in there, so if someone's already inserted a value at this coordinate, let me just format this. So if it's an empty list, we're going to say, great, it's going to be just that. But if there's already values here, what we're going to do is we're going to say number plus our values. We could put it in the front. It doesn't really matter. But what we're going to hopefully get here, oops, sorry, I forgot to wrap it and adjust because it is a maybe value, not just a list. Oh, okay, maybe list, return this in the case where I have stuff. Maybe. Oh, this is a maybe. Oh, number. I got my stuff mixed up. Let's do it this way. Let's put the number in front of the values. Okay, so now what we're seeing is for coordinate, the symbol at 3, 1, we're seeing it's touching 35 and 467. For the one at coordinate 3, 4, we're seeing it's only touching 617. And finally, for the coordinate at 5, 8, we're seeing 598 and 755. So that was the hard part of the logic. Now all we need to do is say dict to list. So now we've got all these. We're going to say list.filter. And I'm just going to do this in line because I'm sprinting to the end here. List.filter. We're going to say we don't care about the coordinate right now. All we care about is the numbers. We only care about the bottom line here. We're going to say if the length, the numbers, equals 2, we'll keep it. That's the part where we say exactly 2. We're interested in that pair. And it looks like we only have it for this and for this. And so then what we're going to do is map and say we only care about those numbers themselves. And then we're going to map one more time. And we're going to say, let's take the product of those numbers. So list.product. This will multiply inside here. So these two will be multiplied together. We'll get 16,345 and 451490. Those are the two numbers that we got here. So we're almost there. It's the last part. It's our favorite part because it's the end. We can sum those together. We get 467835. Let's take a look. 467835. So I'm going to format this thing. I'm going to save, copy that solution that we came up with here in the video. And then what I'm going to do is I'm going to take my puzzle input and I am going to try it out. We'll see if it works. And I get a very big number, 67779080. Is it right? It's right. It's day 3. We did it. All right. So 3 days down, 4-ish to go. Maybe we go for the full 25. Probably not. At some point, these Advent Code videos just really start to beat it out of you. You know, you're like, I'm too dumb. This took me 4 hours. So we're gonna find that sweet spot. Thanks for hanging out. Yeah, if you want, you can check out the previous year's videos. If not, I'll see you tomorrow for day 4. Goodbye.